Hello, welcome back to our journey learning 6502 assembly using the Apple II. So today we talk about input-output to the console. And we have already done a lot of this, but now we know enough to just make something that's better, something that can be used in pretty much any program you want to print strings in a very effective way. And also we're going to talk a little bit about reading strings from the keyboard in generic ways. So subroutines that you can reuse. So this one should already be quite familiar. So what we are doing here is basically iterating through a string that's defined here on data until we find a 0 byte, and then we stop printing. And this is a carriage return character. So if we run this program, what it does is starts with an index of 0 and then starts at address of the string plus the index. In this case it's 0, so it's going to start at the first character, and this character is 0. It's not, it's an H. Then we print it to the console output, then we increment the index. If we have not gone over 255, we go back to the loop, and then we go to the second character and we, oops, that's not what I meant. So we go to the second character and we keep doing this until we reach the 0, 0. Here this condition basically holds true, and it goes to the end. So this should print hello world, and should be no surprise that it works. Now I want to show you, so the problem, what's the problem with this? Actually, if you have to print one string, this is great. This is the simplest way that you can do that. But in the moment that I have something like this, now all of a sudden, because here it's taking the explicit address of data, if I want to do this for data too, I pretty much have to copy the whole thing and keep duplicating it for each string, which of course not convenient. So there is an alternative that's slightly more complex, but then it's basically you can use for any for printing any string with a generic subroutine. And it actually uses a trick using the stack. So here's what it does. We call the subroutine, we jump to the subroutine print string, and just immediately after the instruction to jump to this subroutine, we have our string. So this is not separate in the data section, but it's actually here. Why is it here? And I mean, this is going to end badly, right? Because once we are out of the print string subroutine, we're gonna try to execute this as if it were in an instruction, and it is not. So I mean, how can this work? So the answer to that lies in how actually the processor knows what is the next instruction to be executed. So when you jump to a subroutine, the processor pushes to the stack the address of this instruction. And when you execute an RTS, what you're doing is a jump to that address that was on the top of the stack plus 1. So this is where we are going to fool the processor to do what we want. And what we want is we want it to gloss over this whole data area and to execute the next instruction that's here. So we want basically to pass the pointer to this address. We want to replace the thing that's sitting on the top of the stack, and instead of having an address that points to this location, we're gonna point to this location. And then it adds 1 and executes the next instruction, which is the instruction that comes after our data. In this case, it happens to be a return from subroutine instructions. So let's see how the magic happens here. So first thing we do is we pull the address that's sitting on the top of the stack. And because this is a memory address and 1 byte is not enough to fully have to contain this memory address, it is 2 bytes long. So we actually do it for the low byte and for the high byte. So we pull it from the stack and we store it somewhere where we know where to find it. And here is where we start printing the string. So we started offset 1, right? Because we want to start. This is the address that we got, right? The location where we have this the print this instruction, but we want the next one. We want this address plus 1, which is going to point to the start of our data. So that's why we start with an offset 1, and then we load to the accumulator the contents of the address that's indicated by the pointer. So basically we are copying this value plus the index, which is 1. So we are pointing here. And if that character is 0, then we want to finish, right? Because that's the end of our string. However, if it is not, we print to the screen. And then we increase the register Y. We increase our offset. We check again for if it doesn't exceed 255. And finally, we, this loop basically is going to print the whole string. So we have removed from the stack the address that was sitting there. We have printed our string. And now what we have to do is to put back on the stack not the address that points to this instruction, but the address that points to this byte. So it's going to start this instruction. So what we do here is we start clearing the carry flag, because we're going to do some arithmetic here that touches the carry flag. So we want it to start with a clean slate. So we have currently in Y, we have the length of the string, right? Because we started with 1 and then we kept increasing, incrementing the Y register until the moment where the string had a character with a 0. So this is the Y right now has the length of the string. So we transfer this to the accumulator. So now the accumulator has the length of the string, and then we add, right? We add to the accumulator the value of pointer. So basically we are summing pointer and the offset, the string length. So this is going to put us here. And once we do that, we put it back on the stack using the push instructions for the high and the low byte. And you notice that we added to the low byte, and here we add to the high byte. And we have to do that because depending on the length of the string, it may be that there is some value, that some carry value, the carry flag may be set. So there may be a bit that has to be carried over to the high byte. And this ADC here, although it's adding 0, we have seen how it works. If we have the carry flag up, then this is going to affect the value of the high byte. So basically what we do here is we add the previous pointer that we had plus the length of the string. So this is going to point to the end of the string. And this way, when we do the RTS, we have finally the processor going to the execute the right next instruction, which is this one. So let's take a look at this thing running. And interesting thing here is it's very easy now to just add new calls. We don't have the problem we had before that was pointing to a certain thing, to a certain data section. It's basically whatever comes after the JSR print string line. And let's see in action. Yep. So here you see this is a bit more complicated, and we had to learn about many things in order to put this together. We had to learn not only about doing console output, but also we needed to learn about the stack, and we needed to know how to add things and how the carry flag behaves and all these things. But now we have a truly generic print subroutine that we can use in real life programs that are going to print probably many strings. So that takes us to the next and final part of this video, where we talk about how to take input from the keyboard, a generic subroutine to do input from the keyboard and put it somewhere in memory. So this is the generic subroutine for reading strings from the keyboard. And we use a monitor subroutine called getLine. And this getLine actually does the heavy lifting for us. What getLine does is it waits for keyboard input, and any character other than carriage return is stored in a non-memory location. So this is always in memory location $200. That's the keyboard buffer. We call it just buff here. And also it is going to echo that key to the console. So as the user types, the keys are shown. So it sounds like the getLine subroutine does pretty much all we want. So why the hell do we need to bother with writing a longer subroutine to deal with that? There's a number of reasons. So the first one is we have to store our string somewhere in our program. We cannot leave it in the keyboard buffer because the keyboard buffer gets reused every time there is a getLine. And this may be done by DOS, may be done by other programs. So we really don't want to leave the thing there. We need to copy the string from buff into a place that we want to keep it. And also, I also discovered, this is not actually explained in the assembly lines book or in other assembly books that I have read, but what I observed in practice is that if you don't clear out the contents of this keyboard buffer, when you go back to the DOS prompt, you get syntax errors, you get all sorts of weird errors, which I believe are caused by DOS getting confused with the contents inside the keyboard buffer. It interprets as something that you're typing. I believe that's what's going on. Anyway, I noticed that if we clear out the contents of the keyboard buffer, we are shipshape. So we have here a subroutine called input string that does exactly that. So it starts out by putting 0 in the X register, and then calling, this is just to clean the X register. So then we call getLine, and the X register, after we come back from the subroutine, is going to hold the length of the string that has been typed. So we then transfer this to the accumulator, and from the accumulator to the Y register. So now the Y register contains the same content as the X register, basically the string length. And what we do then is we go to a buffer, and this buffer thing, it's actually a data region in our program, 256 bytes long, and this is where our string is going to live. So what we do is we start with adding buffer to the string length that's in the Y register, and this is going to give us the first character after the string has ended. And what we do there is we put 0 there, and the reason why we do that is to have the no termination of the string, right? So when we print the strings, we stop printing when we find a 0 byte. So this is that 0 byte. This is the no termination of the string. So after we have done that, because we loaded the accumulator with the contents of the keyboard buffer, and then we have stored this at the whatever is the current offset that we have right now. Then we clean the keyboard buffer here. Basically, we zero out that position, and then we decrement Y. So what we're doing here is we are going to copy our string starting at the end with the no termination, and then we keep going back, decrementing. So we check whether our decrement hasn't gone under 0, and if it hasn't, then we go to this point, this label, which is basically a loop, and you see here we have decremented Y. So first time we terminated the string, and then here we are copying the last character, and then we decrement and we copy the one before the last, and we keep doing that until we reach the beginning of the string. So we both copy from buff, which is the keyboard buffer, into this buffer, which is our final location, and we clean the buffer in the process, and we make sure that our string is no terminated. This is what we're doing here, and then we're done. So then we come back here and we go to a print string subroutine, which is again that very familiar, simpler print string subroutine that we just talked about, which is going to print the contents of buffer. So we do that only to double check if our program is doing what we want, which is putting in buffer the contents of what has been typed. So let's assemble and execute and see what happened. So you see that it works. So when I call the program, I get basically it's waiting for my keyboard input, and then I type whatever. And after I type it, it's shown as I type it. It's being shown on the screen, and when I click enter, basically it copies the whole thing to buffer, to the data location buffer, and then we print the contents, and we see that we have exactly what has been typed. So this is how you do proper keyboard input with the Apple II. So I hope you enjoyed today's video, and I hope to see you again for the next episode.